What is public key infrastructure? A public key infrastructure includes the certification authorities, the physical infrastructure, that is the encryption technologies, the hardware, etc., whatever is used, the formulation and enforcement of policies or procedures, and the entire gamut of services, that is the set of services that are required in supporting the use of digital certificates. Okay, so everything that is related to digital certificate is being maintained by public key infrastructure, or what we call as the PKI. Okay, the PKI maintains all these. Okay, what is the encryption, what is the physical infrastructure that is used, what is the encryption technology, what is the hardware that is being used, what are all the different policies in using, and this everything is being maintained by the public key infrastructure or PKI. Okay, that is a sample. It includes the certificate creation, issuance, storage, and archival. Okay, every certificate that is being issued has to be stored. A copy of it is stored, okay, for archival purposes. Suppose somebody loses it and you want to get it, you have it. Okay, next you have key generation and key escrow if necessary. Okay, it is the PKI or public key infrastructure who generates this key. Okay, and what do you mean by key escrow? Okay, in case and he is going to maintain, he can have a copy of it. Okay, suppose a person loses it, then he can go back to the PKI and get it. Okay, now or say he forgets where he has kept it. Okay, he can always go back and get it. Okay, an application of this could be document will has been prepared by a person. Okay, now when is this will used? Only after the death of the person. Okay, suppose the family members don't know where he has kept his key. Okay, then how will they be able to decrypt this document? Okay, they will not be able to do. So they can always go back to the PKI and give him all the details. It is the responsibility of the PKI to check whether the request is genuine. Okay, if it is genuine, he can go back to his archival wherever he has stored, take the key and give back. Okay, next you have certificate or key updation. Okay, maybe somebody finds that an attacker has taken the key or the key has been compromised, then he can always ask for a change of the key. Okay, next we have certificate revocation. We'll see what this is just after this topic. Yeah, so all these things are the functions of the PKI. Basically, the most important function of the PKI is to provide a safe archival for all the certificates that he is issuing. Now, there are certain differences between what is between the public keys, between the public keys used for decryption versus the public key, the private keys that are used for decryption versus those used for signing. Okay, for decryption, it is the receiver who has this private key. Okay, and he can always take a backup of this decryption key and he can keep it for safekeeping. Okay, so that if a key is lost, he can always use this backup. Okay, whereas the one that is used for signing, you cannot take a backup. Okay, why? This one is given to a particular person. It is to identify a particular person. Okay, that is, the document is coming from this particular person. Okay, so he cannot have a second copy of it. He should never go to take a backup. Okay, because in case that is lost, then you lose your entire hold on all the things that you have signed. Okay, so you cannot take a backup for this one. So the important function of the PKI is to provide a safe archival facility for all the issued certificates. Okay, so now you know what a PKI is. Okay, now what are the different architectures for given for the PKI? Okay, we have different architectures. We will see what they are. The first kind of architecture is the PKI with a single certification authority. Okay, what do you mean by this? Okay, you have one single certification authority who is going to issue this digital certificate to, say, user one. Say your second user asks, then he issues the certificate to the second person, and so on. He issues to all the different users, whoever requests him for this digital certificate. Okay, this arc that is shown from the certification authority to the user is what is called is the trust relationship. Okay, this arc from the certification authority to the user is the trust relationship. Okay, so in this architecture, PKI with a single CA, you have a single certification authority who is going to issue the certificates to the different users. Okay, of course, the architecture is very simple, but then it is not scalable. It is practically impossible to have one person issuing certificates to so many different people. Okay, so it is not possible to have such an architecture. Okay, what is the alternative? We have a second architecture, that is a hierarchical or tree-based PKI architecture. Okay, here, what is it that we have? We have CA1, okay, who issues certificates to CA2, CA3, CA4, etc. Okay, that is, he is issuing the certificates to different certification authorities. Okay, now in turn, these certification authorities can issue the certificate to other certification authorities or to the end users. Okay, so here you see CA3 is issuing certificates to CA6 and to U4. CA4 is issuing to U8, U9, U10, U11, etc. Okay, now the CA5 is issuing the certificate to U2, U3. CA6 is issuing the certificate to U5, U6, U7. Okay, what do you mean by this? Say CA5 is issuing the certificate to U2. This arc is what is called as the trust relation. Okay, now what this indicates is CA5 is vouching for the certificate that U2 has given. Okay, that is, CA5 is telling that the certificate that U2 is having is an authentic one. Okay, I have only issued this certificate to U2. You can be sure that U2 is a legitimate or authentic user. Okay, and this is his public key. Whatever is given in this certificate is his public key. You can use it authentically. Okay, that is the meaning of CA5 vouching for U2's certificate. Okay, now, yeah, one second. Suppose U1, suppose user U1 needs U5's public key. Okay, then what is it that he has to do? He requests U5 for the digital certificate. Okay, now U5, when he sends the digital certificate, he has to send CA1's digital certificate, he has to send CA3's digital certificate, and the certificate issued by CA6. Okay, how is U5 getting the digital certificate? He is getting it from CA6. Okay, how is CA6 getting his authority? He is getting it from CA3. How is CA3 getting it? He is getting from CA1. Okay, CA1 being the root, he is called as the trust anchor. Okay. All the users in this architecture will have the public key of the trust anchor or the root certification authority. Okay, so U1 has the public key of CA1. Okay, now when U1 is requesting U5 for his digital certificate, U5 has to give this entire chain of certificates. That is CA1 certificate, that the certificate that CA1 has issued to CA3, the certificate that CA3 has issued to CA6, and the certificate that CA6 has issued to U5. Okay, you can see this. Okay, so U5 gives all these three certificates. Now U1 will use CA1's public key. How does he know? U1 has the public key of the root certification authority. Okay, so he uses that public key on this certificate and he gets the public key of CA3. Okay, now in this certificate that is issued by CA3 to CA6, you will have the public key of CA6. Okay, so he will use the public key that he has got from here, CA3's public key. He will use it in this certificate and he will get CA6's public key. Okay, now from this certificate, the third certificate, that is what CA6 has issued to U5, he will use CA6's certificate and he will get the public key of U5. Okay, so that is the way in which U1 will get the public key of U5 through this chain. Is it clear so far? The hierarchical based PKI? Yes, then I will proceed. The next kind of certificate is mesh-based certificate. Okay, what is this? Here, the CAs have mutual trust. CA1 trusts CA2, CA2 trusts CA1. Okay, and you have different CAs with this mutual trust. Maybe you have a CA4. Each of them can also be issuing certificates or having trust relationship with different end users. Okay, so this is a mesh-based PKI. Yeah, you can see this here. CA1 is having, now you see that the trust relationship that you have is bidirectional. Okay, meaning CA1 trusts CA2, CA2 trusts CA1. Okay, or CA1 is vouching for the certificates issued by CA2, CA2 is vouching for the certificates issued by CA1. Okay, now same way you have CA3 having a relation with CA1 and CA2, CA4. Okay, and it is having a unidirectional relation with CA5 and CA6. Okay, so this is an example of a mesh-based PKI. Okay, what is the advantage that you have here? Okay, now suppose U1 wants the digital certificate of U7. Okay, now in the previous one we saw that we had only a single path. Okay, so if any of the keys in that path is compromised, then the entire path is lost. Okay, whereas here U1 can get the certificate of U7 through different paths. He can take this path U1 to CA1, CA1 to CA2, CA2 to CA4, and then to U7. Okay, or he can take this path CA1 to CA3, CA1 to CA3, CA3 to CA4, or he can take a third path CA1 to CA3, CA3 to CA2 to CA4. Okay, so you have greater resilience in the event of one or more of the CA's public keys being compromised. Okay, so that is the major advantage of mesh-based PKI. The fourth structure that we see is the bridge-based PKI. Okay, say here you have an organization. You have one organization where the entire setup is, you have a very secure setup. You have a certification authority, CA1, okay, who is taking care of all the public keys in the organization. Okay, you have a second organization wherein whose public keys are also well taken care of, or all the keys that are being generated are very secure and is being taken care of by CA2. Okay, now these two companies or organizations want to establish a secure relationship between themselves. Okay, you don't want to establish any relation between the members of the organization. Okay, what we do is, in such a case, we have a bridge CA that is being created. Okay, bridge CA. This CA will communicate with between the representatives of the two organizations. Okay, so these representative certification authorities will interact through the bridge CA. Okay, you will not have any communication directly between the two organizations. Okay, since both are well set up, you are not going to disturb the relation between the two organizations. Okay. Excuse me. Organization A has got its own setup. Organization B has got its own setup. Now, only CA, the representative CA of A, will communicate with the bridge CA, and the representative CA of B will communicate with the bridge CA. Okay, so there is no disturbance to the entire setup that you already have. Okay, that is bridge-based PKI.